Alright, this is review part 2.2, which is polynomials. The first thing you're asked to do is use your leading coefficient test. Okay? When you see describe left and right hand behavior, that means the left of your graph and the right of your graph, how does it behave? Does it rise or fall? So you look at your degree. Okay, this is an even degree. And then you look at your coefficient. This is a negative coefficient. So an even degree, you should be picturing a quadratic, a parabola. They act in the same on the left and the right. Negative means it's going down. So here it would be fall left, fall right. For number 30, it's an odd degree and a positive coefficient. When you have an odd degree, you should be picturing a cubic. And this is positive, so remember cubic looks like this. So it is falling left, rising right. And that does not say fall 6 feet, even though y'all say my LE looks like 6. Whatever. Alright, 39. This is the multi-step part. Step 1. Apply the leading coefficient test. So we know the end behavior. Odd, negative. So it's going to be the reverse of the cubic. So it is fall left. Oh, I'm sorry. I didn't actually reverse that. Okay, the reverse of the cubic is this way. So rise right. Oh my gosh. Start this over. Alright, 39. This is the multi-step problems. Part A asks you to apply the leading coefficient test. This is an odd degree. This is a negative coefficient. You should be picturing cubic. Negative flips it over. So this is rise left, fall right. Part B asks you to find the zeros. You set your original function equal to 0. You can't factor this. There's a couple of ways you could do it. You could use quadratic formula and find your roots. Or for time's sake, you can use your calculator. I'm going to show you how to do this in the calculator. In your calculator, you go to y equals and type in your expression. Ours was negative x cubed plus x squared minus 2. Okay, you can look at your graph if you want to. Okay, but it's really our table that we want to see. Okay, we see where we're crossing the x-axis. Double check in your table what that exact value is. When you're on the x-axis, your y is 0. So in the y column, when you find 0, that is your root, or your x-intercept, so negative 1. Okay, so I'll take a shot of that and put it on there for you. Okay, because of this table, we know that our root is when x is negative 1. And that's the only one. It's only going to cross one time. We know from our n being 3 that we can have at most 3 roots and 2 turning points. But in this case, we only have 1. Give yourself a quick sketch of the x-axis so you can see what intervals your zeros are going to break your graph into. Okay, our only 0 is at negative 1. So at negative 1, our graph splits into intervals. So we only have 2 intervals for this problem. So your table for part C, it says find or plot sufficient solutions. That's your test interval chart. So you'll take your interval, you'll pick an x value in that interval, evaluate it to get a y value, see what that sign is, and list the point that we're going to plot. Okay, so we said it's only 2 intervals because there's only one root. So that first interval is from -infinity to -1. The second interval is from -1 to +infinity. Any x value can be picked in this interval. I told you I'll try and choose the lowest integer that you can. Okay, so that would be -2, and here I'm going to use 0. When I plug those into my original equation, that's how you get your y value. So it was -x cubed plus x squared minus 2. When you solve this, you get 10, so that's your y value. Okay, if you replace those with 0, the value you get is -2. So the sign is positive and negative, and the point is -2, 10, and 0, -2. So these are the points you're going to plot along with your root. So now your graph will look something like this. I'm going to give myself a little room since I know I have to go all the way up to 10 on the y-axis, and I'm just going to count by 2s. On the y-axis. Make sure you label some of them so I can tell what you're counting by. And then on the x-axis, I can just count by 1s. Alright, so my 0 was at -1, and my solutions from my test interval chart, I'm sorry, not my solutions, my interval points are -2, 10, and 0, -2. Okay, so you can graph this. Okay, you can double check with what we found earlier. We said that it should rise left, fall right, and it does. We have our root, our test interval points, we're done. 40, same steps. First thing is your leading coefficient test. That is odd and positive. So you're picturing the cubic. That is fall left, rise right. Finding your zeros, you set this equal to 0. Here we have a common factor, so we're going to factor that out. We can take a 2x squared out of both of those. That leaves me with x plus 2. Now I can split and solve. I set each factor equal to 0. That gives me -2 here. And if I divide by 2, 0 divided by 2 is still 0. And then the square root of 0 is just 0. But I do know that this is a repeating root because I have that squared. So it would really be plus or minus 0. Okay, so when you have a repeating root, just remember that that tells us if it's going to cross the x-axis or just touch it at that value. So here our n was an even number, so that means it's going to just touch at 0. So we know that when we have our 0 at 0, we're just touching there, we're not actually crossing. Okay, I'm going to go ahead and break my x-axis into these intervals at -2 and 0. So that's going to give me 3 intervals. So your chart will have 3 sections. So interval 1, 2, and 3. So your chart will look like this. Don't forget, you'll have your x value, a y value, the sign, and the point. Okay, so the first interval is from negative infinity to negative 2. The second interval is from negative 2 to 0. And the third interval is from 0 to positive infinity. I can pick any x value in these intervals. I'm going to choose negative 3, negative 1, and 1. When I plug those values in, you can use your calculator. Just make sure you're using parentheses. So that, for instance, when you do the negatives, that you're actually squaring the negative, not just the 3. Okay, so you should get a negative 18, 2, and 6. That is a negative, positive, positive. The point is negative 3, negative 18, negative 1, 2, and 1, 6. Okay, so now we can plot those points and our zeros to have a graph of our polynomial. Okay, on this one, I have to go all the way down to negative 18. So again, I'm going to count by 2's. 2, 4, 6, 8, 10, 12, 14, 16, 18. And these are by 2's. That's a negative. Okay, and I'm going to have to go up to 6. So 2, 4, 6. And my x values, I can just count by 1. All right, now plotting your zeros, they were at 0 and negative 2. And the points from your test interval chart were negative 3, negative 18, negative 1, 2, and 1, 6. Make sure you are doing your review on graph paper. Not the whole thing, but at least your graphs have to be on graph paper. So when I go to sketch this polynomial, I'm going up, I come back down, and go back up. Okay, so notice I do just touch at 0 like I said we would. And let's check our end behavior. Should we be falling left, rising right? Yes. So that is a sketch of our polynomial.